Thanks.
Okay, so what I was going to do is, so we have a really buggy project, which we apparently have money from the NSF from, but God knows if the government's still running next week. So, and this is something, so this sort of emerges from my general interest in authentic assessment, real meaningful assessment. So I have a little background, and then I was going to draw everything on the board, but then I decided I'm suffering from some kind of emotional problem, and my handwriting is not good at the moment. You can actually tell exactly how I feel inside by my handwriting. So, and it changes dramatically, which if you're psychology people will know that that's a symptom of something, but keep it to yourself. So, there's no need to enlighten anyone else. So the way I approach this, and I'm approaching this together with my close collaborator now, Melanie Cooper at Clemson, is this this whole idea of science education in general. And I have to say that I'll read any book about Socrates that I can find. This is a new one, and it's great. If you're interested, it's called The Hemlock Cup. So that may be a warning to you. So. The whole goal of education is to get students, I guess depends on your perspective, get students to some desired understanding and mastering some set of skills. And so if you start to think about what that means, normally we're assuming that they're coming from some ground state, which is either blissful ignorance or the wrong knowledge, something that's not right. And you're trying to get them there, and this process of getting from one place to the other, which is of course done by the student, is learning. Okay. And so that's what's going on, and the idea then is that teaching is acting as some kind of catalyst for this process, because the materials that are to be learned already exist. The teacher is not creating them in general, and where the student starts from and ends up, we can think of that as a reaction. And if we want to appeal to the chemical people in the room, there are various energy barriers between those two states, and some of them are bigger than others. So we're thinking of teaching as a catalyst, which I think is a more sort of appropriate way of putting it, because it takes some of the It puts the emphasis on what's actually going on, which is learning, rather than teaching.
Catalysts don't get used up.
Yes,
well, and that's
not get used up then.
That's true. So we'll just have to scrap that analogy.
So you said, as opposed to what, Mike?
As opposed to, there's a kind of a focus often on teachers as teaching without regard to assessment. And so I'm very much interested in the idea that if your students don't learn, you're not teaching. I mean, you may be doing something entertaining in various ways, but you're not teaching if the students don't learn. So the question is, how do you know whether students learn something? Well, you have to give them an authentic assessment, and we'll come back to that in a minute. I'm not going to go. This is not a long talk, right? So there are less than 10 slides here. So.
Do you mind if we interrupt you?
I do not mind. You can interrupt at any time. It's short.
So this is somewhere between like a theory of knowledge and practice and a list of practical items. I mean, so in some sense, I'm applying a sociocultural frame to this, which is a little bit different.
Right.
Other people talk about this as a sort of you could imagine this fits with a cognitivist framework as well.
I'm coming at this from my simple working class roots, where we're trying to build something. I actually do have I am the child of immigrants. Anyway, so I want to build something.
Yeah.
Right? And that thing I want to build is knowledge or skill in the student.
Right. I'm approaching this like any good scholarly inquiry here. We want to draw from theories and models.
Right. This is a very superficial. I mean, we could go deeper in all of this, but I'm painting this very, very superficially, right? So if the student passes this authentic assessment, the assumption is they know what they're doing. They understand what's going on. They can go on to the next task, whatever that is. If they don't, then we have to come back and go through what might be called formative assessment, Where this, instead of becoming a summative assessment, letting them go through, comes back and says, well, there's something wrong. We have to fix something. The learning didn't occur the way we wanted. There's something else we have to do. So this is this basic learning cycle, I think, idea, where a lot of people love the idea. I know a few people I've been talking to who love the idea, like this continuous formative assessment, where by the time you pass through it, you know it. You don't need to take a final exam, because the process won't let you pass through it unless you know it. This is really different from the way we do things, because, and this is one of my hobby horses, those of you who've read Tristram Shandy lately. So I think most of what we do is sort people. I don't think we care whether they learn it or not. And that allows the university to have the structure it does, right? People who care learn it. People who don't care get disillusioned, dissuaded, whatever. So that's my view. True or not, I think there's a fair amount of evidence to support it.
Can you clarify what, I'm sorry.
No, don't interrupt, anytime.
What is the assessment authentic to?
So
Being
that's...
a student.
Right. No, but to me, that's... So if I make a course, I have to basically want to say, well, what is it a person coming out of this? This is a sort of learning goal idea, right? So my view is you're going to build up some set of learning goals for this course. This would be in here. This would be telling you whether they actually achieve them. To build this assessment, you have to know what this means. So, I've said this a lot. You can write these silly learning goals, and they sound great. They're just like a syllabus. But unless you articulate what exactly it means to know them, what can you do once you know them, then, as far as I'm concerned, they don't mean anything. Right? They're just words, right? And then you can tune your assessment so that you get the result you want. So many people, this is the basis for curving exams, right? I mean, you don't actually care. You just curve it. Some bunch of people pass through, some other people are rejected. It's like a filter, bandpass filter. So wonderful way to teach people. So assessment is, so we start to think about assessment, right? And so I would argue in general that the gold standard is a Socratic examination. You would sit and talk to the person. It depends on whether you wanted to perform some skill. So if my examination is jumping high jump, I would let them jump the high jump. If I wanted them to see whether this is the basis essentially of a PhD thesis exam, which is a Socratic examination, where you would be placed in a position where you had to explain what you meant and defend what you thought and all of that, and you would be examined by people who presumably know. And that process reveals whether or not you're a master of the subject, whether you're talking jive, whether you really are ignorant. All those things sort of emerge from that. Noah?
Doesn't that still sit as proxy to the very things we want people to be able to do, which
Right.
is participate in the culture? We want them to be able to build things, do things, generate knowledge. Say, for instance, for a PhD. So even then, this form of assessment, the gold standard that you're putting out, is stands as a proxy. It's not actually
No, it's
the
not.
goal of what we want to engage people to do.
Well,
I mean, unless sitting around talking to each other is in fact what we want people to do, which happens sometimes.
I think I would respectfully disagree in that I can pretty much quickly tell whether somebody's talking jive or know what they're talking about by talking with them and asking questions. And that's what we do when we
But that's still-
interview
that's-
faculty candidates. That's what we do when we do all those things.
That's
We ask
still a
questions.
proxy for the things that you care about. Whether or not it's 100% efficient, let's say you're extraordinarily good at determining jive from non-jive.
Let's
Right.
get concrete. So
Yeah.
concrete would be
So let's say you're educating a biologist who's going on to work in industry.
right. So the question is, can they do that thing?
Yes.
That's right. And so I would. So I agree. I totally agree with you that the more there are degrees of this, right? So this would be essentially completion of authentic knowledge. So this would be the alternative. So if I throw somebody into a biology lab and say, I want this molecule assayed, then do you assay it correctly? Right? So I mean, I don't see that everything is academic. This is sort of the academic side, and this is sort of the practical side. Right? Because I think there are actually, there's room to think that there's more than one. And I know a lot of people. I've been extremely influenced by this paper, Urzet's Learning and Inauthentic Testing, where this idea that because students get a grade on my test, that means they know it, to me is demonstrably not true. Because there are all these pressures on faculty, okay? And in fact, if you've read this book, DIYU, which is Do It Yourself University, there's a very compelling discussion at the end, which is that teaching and grading are in conflict. Right? So teachers should teach and assessors should assess. And that you can't do both. Because when you're assessing your students, you're essentially also assessing your teaching. So you have a conflict of interest. And so the British model, which would be you go study and then you take a national A-level exam or O-level exam, which is graded independently of your instructor, is a way of disconnecting that. If you're teaching the course, I would argue you cannot objectively assess your students.
That, just to say, I mean, that embodies, I hope you don't mind me sort of engaging.
No, I just hope that anyone else who feels like they need to speak has space to do that. No, but I love it.
Go ahead.
No, I love it.
I was giving a space.
They didn't take it, it's gone now, baby. Nature and
This
Noah
presumes a certain form of practice in its own sense. The sense of objectivity and testing presumes certain paradigm. For instance, our guest would perhaps argue that you have to be embedded within the system to have intimate and hence subjective knowledge of the nature of those kinds of practices.
You know, I used to live in Berkeley, and I remember hearing people talk like you at Berkeley, and it just makes me so nostalgic.
You can dismiss me if you want, but there's an entire field of research here that we're missing out on. And what I'm pointing out is that particular paradigm and epistemological commitment about the nature of knowledge itself is hidden within this. And I'm not saying that it's wrong, but you're making assumptions about what it is that we value by your forms of assessment here. And
Absolutely. I mean, when somebody says they're giving a test and they're putting it on a curve, they just told you what they care about. Right? There's unambiguously the case that they couldn't care less whether you're learning it because they're giving 20% of the people A's and that's it. Screw you.
Right.
And they're giving you the top 20%, whatever what that means.
Well, likewise, if you're analyzing it with a statistical model, you're assuming that it's going to form that normal curve.
You are, but the question becomes, if I draw this, if I say, well, why can't I move the mean of that curve over to beyond the area of competence, right? So most places, we're going to put the mean in the middle, and it's okay that these people are at the, these people are on the side, but I could change the course to move the mean over, so that I got a higher percentage of people understanding it.
Or change the measure from mean to mode,
Right.
or something that...
I agree with all that, but I do think one must realize, sort of objectively, that the goal of universities is not to educate people, it's to sort them. And so, as long as it's to sort them, then it'll sort them, on whatever criteria. I do have a basic proletariat mindset, so. With little or no compassion for the ruling class. Anyway, so we make all kinds of compromises when we do evaluation. So I couldn't decide which to go first, but I'll start with multiple choice tests, which are clearly a compromise because they're designed to be graded easily. Okay, and we built one, right? So this is the BCI, which is now available in archive, and so you can get it. This is a wordle of all the terms in the BCI, and the question is, it's a multiple choice test. It has all those kinds of things that are wrong with it because it's impossible to build such an instrument that's unambiguous. It just can't be. I don't think it can be done, and I think thinking it can be done is a mistake. And what I would do if I was going to make the BCI more valuable, and I'll talk to you a little bit about textual coding, is I would ask students to tell me why the wrong answers are wrong. Okay? Because I don't care whether they recognize the right answer. Of course, they've been told the right answer, presumably, but they may not know why they're rejecting the wrong answers. So to me, this is the way of seeing what students actually get. tell me why it's wrong. Students they have a very hard time doing this. And it's very easy to convince yourself that students know something when they don't. They just recognize it as not being wrong.
Mike, you said it's a compromise.
Yeah.
I mean, do you admit that it has some use, or?
No, they all have a use. It's just a mistake of, there's a philosophical fallacy called what's it called? The fallacy of misplaced concreteness, right? So you can actually think that your test measures something that's not real. I mean, it can be informative, but don't think that because they get a score on that test, it means something. It may mean something, it may be a useful indication, but it's not enough. Okay? That's my view, right? It's just the beginning. Now, a compromise, so this is a compromise. So essay tests represent a kind of compromise, okay? Now the problem with essay, and I mean, these are the papers I tell everybody all the time. And these are on the bioliteracy website. The papers are there, okay? So their PDFs are there. So this is an argument by these guys in chemistry basically saying, you tell me what you think the learning goals are of your course, and somebody not associated with the course will generate 2 or 3 essay questions without your knowledge of what they are, and then they'll give them to the students, and somebody else will analyze them. Okay? Now, I love this model, and I'm actually, since I'm currently on the BFA, pushing that all departments analyze their core curriculum and outcomes using this kind of model where maybe the Center for STEM Ed plays a role in this analysis, and I'll show you what I mean by the analysis. But this is a very interesting way of getting this is an A-level model. Somebody generates a set of questions that are presumably covered, and you get an analysis objectively, and then you see what's going on. So this is one. So we've been working, Kate Henson and I have been working on this, and Melanie too, which is, here's the problem with essay responses. They're contradictory. They're not graded in a coherent way. A single essay question, that should not be there yet. So a single essay question can have within it statements that are correct.
You mean the answer?
Yeah, I mean, the answer to the question can have statements that are correct, statements that are incorrect, statements that are irrelevant. Okay? So in a sense, we would argue that such an answer should be coded in a 3-dimensional space as a vector that indicates how much of each of them are present. Okay?
For an item?
For a particular item, you would decide how you were going to code it. So a particular essay question could have 5 components to being completely correct. So that, how many of those would be running along this axis? If you got all 5, you'd be out here. If you had a lot of irrelevant stuff, you'd be here. If you had incorrect stuff, you'd be over here, right? So where you are in the space gives you an idea, because the premise of this analysis is that, and we're actually going to try to, part of my little subterfuge, we're going to teach I think we're going to teach a section of the intro course in MCDB. We're going to use this analysis because I have money to do this, to look at students in one version of the course versus another. And the assumption is a coherent, clear understanding of this would be a vector on the x-axis.
What if you got 3 of the things correct, but you didn't mention the other 2?
Then you would get a 3 on that. You would get a vector 3.
And then 3, 0, 0, right?
3, 0, 0. Unless you filled up your answer with lots of jive, right? You did a poor dump. Seth.
Why is it important to distinguish between wrong and irrelevant in terms of their understanding of the material?
Because I think, in fact, that when you're talking to somebody who knows what they're talking about, they don't say irrelevant things. And irrelevant things are... So the question is, how do you... Say that again?
I've never met one of those.
Yeah, well,
but
me neither. Me neither, Valerie.
I think what he's saying is there's things that are unrelated.
Unrelated, irrelevant, don't address the answer.
Related, but they're scientifically wrong would be wrong.
I think Valerie used this term. This is sort of this may emerge, nobody has a new idea in this world. So this may a word emerge partially from Valerie. What were you calling it? Swoozing, right? You're just saying everything, and because you're trained to know that if you say 3 or 4 right things, you'll get some points.
Well, wait a sec, but Valerie claims that that's a good developmental step.
It may be a good developmental step. This is a test.
But it wouldn't be coded on the x-axis because it shouldn't be.
No. So, I mean, so there's a difference between the process of getting to understanding and understanding.
So wouldn't there be a fourth axis of irrelevant and wrong versus
Oh yeah, but that's why that's why we don't. No, irrelevant wrong is just a dot in vectors in space.
Wouldn't that be the worst thing though, irrelevant?
We're not judgmental. The worst thing. No.
What you're talking about.
Right.
Yeah, maybe.
Well, I mean, the more errors, the bigger your vector is here, the more irrelevant. I mean, so I don't think you need 4 dimensions unless you're doing a pre-post test.
Irrelevant stuff doesn't need to be evaluated for correctness.
It doesn't. No, if it's irrelevant, you just lock it up as irrelevant, right? And so,
How do you code since you put out the claim before that you want students to be able to say why the wrong answers are wrong, how would that be coded on?
Oh, that would, if they were explaining to me, but this is an essay, but
Yeah.
that would be correct. If they told us...
Even if you don't say why the right thing is right, but you say
No,
why
but
the
if
wrong things are wrong?
Well, I don't know. I've never seen somebody write an essay explaining why all the things that they didn't put in the essay were wrong. Yeah, but I'm still relatively young.
Yeah.
Well, not really,
Well, just-
actually, tragically.
Depending on the universe you are.
I wouldn't say what I think about the universe in general, but nevertheless, we're trying to keep it clean here. So anyway, so you can imagine this is a structure, a framework for coding essays. Whatever, nothing is perfect in this. Everything's a compromise. So this is where the student is, right? The idea would be this is where the student is, in some place, right? And this is where, and you'd want him to be there. Right? So it gives you a more nuanced view because in practice, most instructors do not like taking points off for irrelevant or wrong thing in essay questions because they don't want to have to argue with the damn student after the final or whatever. Particularly if the student says something that's right. So those grades essentially almost always overestimate their understanding.
Can I ask who this is meant to? So this is for coding, but who uses this?
I would propose that this is a very important evaluation to see where students are with pre-post analysis.
So who's using that?
Probably researchers. I think it's too much trouble for normal faculty unless you could build a linguistic system that could do that, which
Because
is not
I'm thinking, why
impossible.
not just a table of irrelevant, wrong, correct with 3?
Well, you could do that. You could do that. That's the data that makes this graph.
So, but this is like a
And visually
representation. This is
centered.
a representation that you and Melanie generated, isn't that correct?
Yeah, and Kate Henson.
And Kate, okay. But
Well, actually,
so this is like it's like a hybrid between the get it or don't, did you get it right or wrong, which is the standard mode of operation for most teachers. And then the kind of formative assessment model where you're like, what do they get? What do you know? And you're trying to just find out what they know, whatever it is you want to know. You don't care if it's right or wrong, you just need to know so you can build on it. This is kind of like somewhere in between where it's like, of the possible set of correct and incorrect answers, where do they live? It's not the flat linear get it or don't. It's a three-dimensional get it or don't model.
Right.
Which is a nice.
It's another dimension. It's like the multiple choice asking them whether wrong answers are wrong is adding another dimension to that too. Right? Because they probably don't know why, in most cases, why the wrong answers are wrong, or they're not articulate about why the wrong answers are wrong.
I might also argue that in some ways the irrelevant factor could be trained out of students. That I agree with what you said, that a lot of that comes from students just trying to regurgitate as much as possible in order, hoping that they say something right. And I guess there is maybe there's a difference. If they're just trying to put down everything and they don't know the difference between what's right and wrong, then you don't make that separation.
Training, I get it. I don't know how you can train it without seeming draconian.
Isn't that a metacognitive skill?
Yeah, but it's also about, and feedback about how you train.
Well, I'm talking about authentic learning, which means The kind of learning I want is the kind of learning when I go in and my car doesn't run, I don't want the guy telling me all the different parts of the car and what could be wrong with them. I want him to tell me which part's wrong.
What you want him to do is you want him to fix your car.
I want him
You
to-
don't want him to write a paragraph on it.
Right. No, that's right.
This is why it's a problem.
Right, exactly right. But if the person were going to write a paragraph, it would be, this is the order in which I'm looking at it, and I know why I'm looking at it in this order.
Yeah.
Right? No, there's no perfect assessment. So this is another one that we're really interested in. So this is the major one that I'm going to talk about today, because this is the one that we're developing with Melanie Cooper and Sam Brzezinski, and we are building this sort of for a number of reasons. So it emerged out of the chemistry project, and so this is a wordle of all the words in the chemistry book, and so you can see that it's sort of chemistry, molecules and reactions. So it's kind of chemistry. I was very relieved to see that. It's kind of, and this network thinking project that we did with Caleb Trujillo, who's now at Purdue in bioed, and actually maybe bio, it's hard to tell. And so we were searching for alternative methods, and we sort of went into this model, and so the logic of this model is, I think the logic of this model is here. Students typically make unambiguous graphical responses. It is the rare student who draws 5 graphs to answer a problem that requires a graph. Those people would probably be hospitalized immediately. But the point is that, you ask somebody to draw a graph, they almost always draw one line. So that's the logic. Graphical responses can cue targeted responses from the system. So we're trying to build this as an automated system. So it works in the sense that the system recognizes what you're drawing, and for example, if you draw a Boltzmann distribution and it's symmetrical, it recognizes that it's symmetrical and says it shouldn't be symmetrical. Do you understand why it's not symmetrical, or do you really want it to be symmetrical, or whatever? And then it really facilitates what we would call perturbations. So we have this model where we're doing 2 things. We're doing prods and perturbations. So this would be a prod, right? So it's like you draw it symmetrically, and you say, what? You really mean it to be symmetrical? Should it be, that would be a prod. A perturbation would be, oh, it looks like you drew it correctly. What happens if the temperature goes up 100 degrees? Okay. What happens if the number of molecules in the system decreases by a half? So you can do all these variations on a theme, which now you're not prodding them, you're just checking whether they really get it. Because in theory, if they really got it, you could be confused.
How far they could get.
Well, you could have herded them into the correct graph, because your prods will flag when they're doing something wrong. Okay. So you'll herd them into the correct thing. Now you could stop there and think that they knew it, which they probably don't, but if you do a perturbation that requires them to change it. So, for example, in a Boltzmann distribution, when you ask people to draw what happens if the temperature goes up 100 degrees, they very often just make the whole graph taller around the original site.
And then do you get a vector out of this after they're done?
No, we're not.
They should go straight to a vector, because when you start doing the perturbations, it's not like suddenly you can say, oh my God, they don't get it. It's like they got somewhere.
No, they got, and you
There's
can.
somewhere on that graph that's not on the wrong.
I'll show you
axis.
this. We capture everything they do. So this is actually emerging also out of Melanie Cooper's organic pad system, which we are now putting on iPads and stuff like that. So the organic pad system is a free form, draw this molecule, draw this reaction, right? So it recognizes when you draw it, it thinks it knows what you're doing, it looks, and it captures everything the student does. When they draw something, when they erase it, so you plot their trajectory through the problem, which sort of underemployed education researchers can spend the rest of their lives analyzing. So, but it generates, it's like genome studies. It just generates millions of gigabytes of data, right? So But you get a trajectory of everybody, and they've done analysis using hidden Markov models, which I barely understand, to figure out what are the major ways through the system. Okay. So you get all that data. And so what we did is, so Melanie's group had that working on a tablet PC. And we decided, and then Sam, who's just amazing, said, I can put this all on the web on Silverlight. I don't know how he did it, but he did it. So now it works on the web. Right, so now you can draw, and because Melanie is into embodied cognition, which is, if you move your body around, it helps get things understood, which is essentially a variation of when you say something stupid, it sounds more stupid than when you think something stupid. So we're very interested in, how much can we make people move things around? How much can we make them interact with the system? So this is an example of one that we're working on, and the system's really buggy at the moment because we just built it out of nothing, and it's sort of, I'll show you one or two, but so this is the network one that we're starting on, and I was actually going to, but I don't think this is the right thing to do. I was going to give you out things to do, but my printer is too slow to print two-sided fast enough, so I'm not organized today. But this is an example of a question. This is the network one applet. So we're very interested in the idea that I'm very interested in the idea that how students in biology understand emergent properties. So we talk a lot about genes and proteins and how they interact and produce behavior, but students never do that, essentially. So this is part of that, and I'm also working with Kathy Perkins and the PhET group to try to build a bunch of applets that let you build your own genetic circuit and watch it behave and sort of try to engineer it to produce various behaviors. And with or without noise in the system, which is the good bit. So, but this would be the beginning of this. We're building various kind of tutorials. So here it is. Here's a gene. The information is in the DNA. It's read out by processes of transcription, which is the synthesis of an RNA molecule. I don't want to alienate anybody with too much biology. It's most commonly those are translated to make a polypeptide. Polypeptides then assemble into proteins. Both of these are dynamic processes controlled by macromolecular interactions. Everything that goes on in the cell is just diffusion limited mainly, and things bumping into one another. They're a network, and these activities are designed to get you to think about it. So basically my goal is to get people to appreciate that putting 4 genes together in various ways can generate extremely complicated behaviors. And non-intuitive behaviors. Right? So you don't need much complexity to get complexity. So it's sort of also an evolution issue. We start with a simple system, 1 gene, encodes 1 polypeptide. The length of the rectangle here is the coding sequence. The diameter of the circle reflects the length of the transcribed region, size of the polypeptide. The idea here is for people to realize that it takes time to make these things. Okay? So the longer the transcribed sequence, the longer it takes to make. All those, those are things that most students, in my experience, teaching and learning biology, some of our best students don't understand. Surprising that somebody could come through a molecular biology program not understanding that. Nevertheless, not uncommon. But I don't have chapter and verse, but I could get it for you if somebody would give me a 50K or something. So, because it's true. In this system, there's no transcription until S is added. Okay, and when it's present, transcription is maximal. So one thing we have to do is really think about what we're trying to do, make it simple. So so part of the system, it also captures textual responses. So you can say, well, predicting the behavior of the system requires one to understand the fact that biomolecules have a half-life. Okay. Which means that what does the term half-life mean to you? Once you start to think about this, you realize that as soon as a polypeptide is made, it has a probability of being degraded. So when we talk about the shape of the curves, the reason they're sigmoidal all the time is because the degradation is a concentration-dependent process. It's not a time-dependent process in a sense, right? So it's a probabilistic process. It is time-dependent, you could be made and degraded right away, or you could be made and degraded a long time ago, but the population of molecules will have a half-life. So half-life actually is an interesting concept in biology, which I haven't seen anybody teach, actually, but I don't go to every class. So then you would have now you have a question like this. try and predict how this simple system behaves. At time 0, concentration of the polypeptide is 0. You add S at 2, and then you let it go, and it reaches maximal expression at 12. And you're asking people to draw a graph. Now, we've done this in various courses, capstone courses. We've done this in capstone courses. And in fact, students will start synthesis from 0, even though they're told it's not true. They will draw straight lines, even though the molecule is being degraded. They will not have it plateau. They'll do all kinds of there's all kinds of interesting things going on. They get better if you let them work with in groups, but they don't. This is surprising because they finish the core curriculum of the department. Okay? You wouldn't expect them to be molecularly naive, or I wouldn't. So if, in this system, if you were online, and I'll show you one, but this is not interactive, you can draw this with your finger. When it's on the iPad, you can draw with your finger. Now you have to draw it with a mouse. It's harder. I find it very hard to draw with a mouse. So, and then you can adjust it. When your curve goes up, it gives you fiduciary points where you can pull it all over. You can erase it. You can reset it. And then you can check it. Right? So it will use its system to decide, you started out with A being not 0. It's got to start at 0. Or it's linear, it should be sigmoidal, not linear, or so things like that. Then you can start adding complexity. This is actually not the second. This is not the second frame of this applet. This is the second applet in the series. So for example, in this one, we would ask, the perturbation question would be, well, what if we took S out of the system at time 6? What would happen in the system? And then we would expect them to change what they did. Or if we said, well, what if the half-life of polypeptide A is 1/2 of what it was before? Or what if the length of A was 1/2 of what it was before? What if it was twice as long as it was before? Or those are all perturbations, which we would argue if they really understood it, they would draw correctly. If they didn't really understand it, they would draw incorrectly. So that's what we're doing. And so this one is a double. Right, so the gene A is turned on, product A turns on gene B, and then you can see how you could build this. So the next one in this series is protein B coming back and inhibiting the activity of protein A. Right, so you start looking to see, can you understand how that system works? And there are many assumptions you have to make. So does it inhibit protein A, or does it increase the degradation? Does it change the half-life of protein A? And you can imagine that an AB dimer behaves differently and regulates different genes than A or B alone. There are all these, this is biology, so anything you can imagine probably occurs. And so, don't get too excited by that thought. So, it's a biology joke. There's a great little article on the Science News about sex role reversal in aphids or something. So those of you who find the rest of my talk boring can go there. So you can imagine all the things you can do, and this is the prelude to this whole thing because it's not stochastic. Right? So in a normal biological cell, there are not that many molecules going on, so there's noise all the time. Right? So that's another issue. So that's what we're doing. So I think, so I wanted to end here and then sort of show you what it looks like. No, we don't want this. So the system is working. Okay, and you can ask to log in. This is an example. This would be an example of how this system would work. So it says, now here's another graph. So you can watch, this is a little movie, but this is canned movie. We can expand it. Ooh. So please draw a graph showing the distribution of velocities in helium atoms. Okay, so this would be a Maxwell-Boltzmann distribution. And it says, it looks like you draw one maximum skewed to the right. Is that what you meant? So these are all in the process of being researched as to what the appropriate responses are. So don't be too critical. So somebody draws it, that looks much better. This is what the system actually does that. So then you go to the next one. So now draw another graph where the velocity, the temperatures increase. So this is the scenario I showed before. This is a not uncommon response to this. You say, oh, it looks like there are more molecules than there were before. Right? So you're not telling them it's wrong. We never say it's wrong. We say what it looks like, and we're befuddled.
Yeah, but if you tell them that looks much better, you told them it's right, therefore if you haven't told
Well,
them
so the
it's
question
better,
would be,
you told
I'd be
them
really
it's
interested to
wrong.
know how else you get around it.
What kind of logic tree does that have? I mean,
So let me show you.
Yeah.
So I'm going to show you what the logic tree looks like. Okay, so come on, let me in. Yeah, I've been things have been crashing all over the place. So okay, so I'm logged in already, so I can look at an activity. So I'll show you that what I'm currently working on is this one. Okay, so this has got, you saw the first one of this is the second one of it. Here's the third one, and let's look at the logic tree. So we start to see the Socratic graph, and we can look at the edit conditions. I don't know if you're going to be able to see this, but we're really interested in having people who are interested in generating questions like this start to think about how to do it, right? So basically what you're going to say is, for this one, we're going to set that there's a slope required, and we're going to make the slope 0, and we're going to set it for this segment. So this is a network problem where you add s at time 0 and there's no a before, which means it's 0 up until 2. I mean, you add s at time 2, sorry. And then it starts going up. Right? So before you add s, it's 0. So you say, well, I want a slope that's at 0 between the region of the graph from x to 2. And then you can control with this slider sort of the slop in the response. Right? So that controls a slope function that says if it's anywhere within that slope, it's okay. And if it's wrong, if it fails to meet this rule, and so a really interesting research question is, what is the order in which prods are presented? I mean, we have money to do that, to figure that out. So in this case, we'd say, well, synthesis of A does not begin until the addition of S, and you should rethink it. So you can imagine various levels and tiers of responses. It's already built in that we can add multiple tiers. So for example, if you did the same mistake multiple times, it could give you multiple feedback responses until it got fed up, or you got fed up, or somebody got fed up. Right, and we do envision failure mode, which is, you don't get it, you better go back and talk to somebody. Right? We're not going to let people pass through it without getting it, at least according to the machine. Right? And if we can't prod you into getting it, we're going to send you someplace else because we can't do everything. So that's the idea, and so here's another rule. Okay, so in this rule, we set it plateaus after 12, so you're looking for the slope to go to 0 after 12. You could set so this is a slope one rather than a y value one. This one says, well, the curve between essentially 2 and 12 should be sigmoidal, shouldn't be linear, right? So linear means you don't understand that there's degradation going on. Sigmoidal means you do, theory. So then you get this response, right? And there are various responses. Once you get to here, then if you pass through all the rules, it will say, oh, it looks like you got it. Can you explain why the concentration of A reaches a plateau after time 12? So that would be sort of the example of what, tell us what you're really thinking. Yeah.
Where does that go? Sorry.
Go ahead.
Where does that go?
Yeah.
That would just be going to the database, because we don't have a system. And analyzing student textual responses would, of course, be the next level on it, but it's way harder than doing this. I mean, I have to tell you, Sam threw this basic system together in like 2 weeks, right? I mean, and it's still not perfect, but it does a lot of stuff now. And we've been using it in the CLUE course at Clemson to look at, arrow pushing in chemistry, where are the electrons coming from, where are they going, all that stuff. So you can do it, that works pretty well. And that's not that far from organic pad, but you can see, you can make organic pad applets through this site. Okay, so organic pad is one of the functionalities of this site. It's built into this site.
So the question is, so it's really impressive. I'm very impressed. But the question I have is like, so Jim Minstrel and the gang did a diagnoser back when, and they give diagnoses and prescriptions, which are similar to
which
the,
is not
the
not
prods,
right.
the prod and
Prod and perturbation.
But the question I have is, one thing that they did do that I think is kind of useful, and I wonder if you're doing it, is once they would try to recognize with their diagnosis what the issue is that the student keeps running up against.
Right.
And so then they would provide another problem that
Right.
they would have another opportunity to face that issue.
Right.
And because you told me now that they're going to do it until you're going to help them get the right answer. Now you have to see if they're consistent in getting that answer.
So the next, exactly right. Right. I mean, here's I believe that there's not, I'll tell you there's a reason why I think Socrates was pretty good. I don't think educational technology has improved that much from Socrates. So, it's a matter of, it's more of a matter of economics than it is about process. I mean, he's walking through the forum with, 5 guys. Right, on a regular basis, probably drinking a fair amount and eating olives, right? So, you imagine, and he got in trouble, right? So the point is, so the next, right? So that's a summary. Well, he got in trouble. So this will give you an idea. It's not working right at the moment. So I'm a little nervous about showing. But so here would be, so you would write in here, what does half-life mean to you? Next to nothing. Right, and so here you could draw your graph, and I could tell you I'm not good at drawing. Okay, and then you can adjust it, and there's something wrong where it's dropping these things in here, which are really annoying. I don't know where that's a different line, so you have to sort of erase it. Yeah, I know, it's annoying. Well, we got to fix. So then you hit the check button. It says, looks like. So unfortunately, I drew it right because I don't want to show you the buttons. But I didn't actually mean to draw it right. But so it looks like you got it. Can you explain? But so if you got this, then you would put your answer in. You go to the next one. It says, well, let's see what happens if we change something. This is the perturbation. What if we change imagine the transcript length is the same, but the polypeptide it encodes drops by half. Right, because it turns out the polypeptide is not the same. It's not uniquely determined by the transcript length. So, and so now this is going to rise twice as fast as it did before, and so it'll plateau, but it'll rise faster because it's a shorter peptide. It takes less time to make it. And so then you would go through this. The rules for this one aren't in. But that's that tree. So there's a lot of research to do around what prod comes first, what people are thinking. So we are doing that on pencil and paper with students in the real world. Here's the problem. What are you thinking when you're doing it?
Seems like it could be nice after all of that to then give them a graph and ask students propose some conditions that would lead to this graph. That would be another way to.
I like that. We're trying to make it very open source, so we're making it so that people could author on it for themselves if they want, and it's compatible with various databases, how we dump data out of it. But I think you could do a lot of different approach. I like that idea, but it's just the idea that you're really trying to get them to tell you what they think, one way or the other, without try to strip away as much of the standard obfuscation as possible. I mean, I think that would be good.
You're already asking them some open-ended questions.
Yeah, I mean, our real problem now is we don't know how to deal with open-ended questions.
Right, I know. And students, if they know that they're not sort of being graded on that.
That's right.
Whatever,
but the whole point of this is not to grade them.
Right.
This is all meant to be formative assessment. This is not meant to grade them. If you want to put a question on your exam and grade that question, fine. We're not interested in grading you on this. Well, that's not the goal of this. But you could imagine that somebody said, okay, here's a G network, here's your graph on your exam, draw it. Anyway, that's sort of where we are, but you can see how it's relatively easy to use with all these conditions of setting up, who is, whether you're in the zone or not in the zone and how you perturb it. So what we like about it is it's very open-ended. There are a lot of problems in STEM that are graphical problems. And in fact, I would argue that part of the problem in biology is people have been afraid to do graphical problems because they don't want to grade them. And you have to provide too much. This gives you an opportunity to let people start thinking about that. And if we had fed applets where you could build a G network, right, with positive and negative feedback and all that stuff, and then watch it behave, then, my dream is that instead of giving people to say, okay, here's the behavior of this genetic system, make me a molecular circuit that does that. And don't worry about if that's the way it's done inside any organism. I don't care, right? So if you know your molecular biology, which most of you don't, everybody learns the lac operon, which is a famous gene system in bacteria that responds to lactose in E. coli. And it's like a paradigm for how genes are regulated in bacteria. It doesn't really mean anything in eukaryotes, but so you memorize this thing. Now I would say that's not as valuable as being able to say, well, how would I build something that behaves like the lac operon? Because that process of learning to build it would call upon all those ideas of repressors and regulating proteins and stuff like that, but it would not require it wouldn't be just simple memorization. And to me, the problem in biology has been too much memorization and not enough thinking. And so
I wanted to ask you about axis labels on your graphs, which seem to have few axis labels.
Yeah, they're not optimal, that's for sure.
If you don't already have a thing built in.
Are you okay?
What?
I just want to make it clear that I did not design that chair. Nor did I buy it.
I want to make it clear that that's not the first time I've done that.
So if I was using this as an instructor, I think what I would want to do is ask students one of these questions and ask them to fill in what the axis label should be. Is that
I think we can. We're working.
Because that's like when I saw the Boltzmann distribution,
right,
which had no axis labels,
right,
and that's where I think you can show the difference between students make the graph or they just make it bigger. To me, that's usually that they don't understand what the y-axis means.
And that's a very good idea because you could imagine. So we could call out these as also conditions.
Right.
So what is this?
You can back into the naming problem.
It's a naming problem, but in some cases we could name them automatically.
You choose from a list.
They could do multiple choice. Here are your choices for X. Here's your choices for Y.
And those multiple choices, though, like Steve is pointing out, come after you've tested it several times and got a sense of what kinds of answers
you might not know what they will come up with.
Oh, no.
Once you come up with 10 possible
Absolutely. So just so we don't believe that this system can run except after serious amounts of research into how students respond to these questions. We already know that. And that comes from us working on the network problems in development and Melanie working on organic pad analysis, right? You really have to know, people have to talk to you about what they're thinking in a way that you have to capture and think about. But you're right. But you could do that. That wouldn't be that hard. And that's very clever. I hadn't thought of putting multiple choice axis labels. That would be cool.
So the other thing I really like is that in this problem, all of your axes have numbers because you're asking them to do things in different
at various times.
But I did like that, for example, in the Boltzmann, that you don't have to have the numbers. Because
No, you don't have to have
dealing with
it.
numbers or not is also very difficult for students.
Right. You wouldn't. We're trying to make it maximally flexible, so the tools are relatively easy to understand. So, for example, if you're authoring this, you could insert into a field. Let's see. Let's say I want a new one of these, a new slide, and then I put an organic pad functionality in here. right? And so this is an organic pad functionality which would allow, when you draw something that looks like a C, it thinks it's a carbon. Okay? And it knows that it's going to have 4 bonds coming off it, and it knows that hydrogens have 1 and all that stuff. So you could put that, you can put in text input, you can have them able to draw. So we're very interested in saying, here's a schematic of a cell, show us where the genes are, show us where the proteins move, so draw with your pen or your finger where they're going. You can put images, you can put video. I mean, you can make it relatively rich in the and then your response. The only reason we really like graphic stuff is that and graphs in particular. The reason this is called Socratic graphs, it's not the whole thing is be Socratic, but it's Socratic graphs because graphs are easier than drawings. Drawings may be easier than text, but we sure know graphs are easier than text.
Okay. As far as analyzing them.
As far as analyzing them. And in fact, the shorter the response, the worse it is. Right? So if you think about, we were originally we would build, our dream would be to build latent semantic analysis or something like it into this system so that when you start talking, it starts responding to you and to say, boy, I sure don't understand what you meant by that. Why were you talking about this? Or something. As opposed to saying, it's it's a compromise. How do you tell somebody that they're not right without telling them they're wrong? Right? That's kind of tricky, right? You want to prod them into realizing that what they're saying is not right. You just don't want to hit them on the head and say, bad dog. Well, you might. You do, but that I'm not convinced that only provokes a reflex response, right? So you don't want a reflex response. You want a cognitive, thoughtful response. Okay, thanks. That was cool.
Thank you.